Hello, thank you for coming. We will wait some seconds just to allow everyone to come into the room. Okay, we are getting more and more people here. We'll give them some seconds of extra time. So, okay, so there we go. Thank you for your time. Thank you for coming here. My name is Ferran Navarro. I am the CEO of SiOCAST. Also, I am one of the co-founders of the company and one of the fathers of this little baby. And today, I'm sure that you are here because you want to understand how this process works, how it's going to be able to transform your miniature business. So let's start with a very short casting. So because I'm sure that you want to know where's the magic in here. Right now, we are doing first shot. This is a coin mold, and we are doing something that people sometimes they don't believe. We are doing injection molding in flexible silicone rubber molds. Okay. Let's see what happens. Okay, so this is casting of the miniatures of the coin mold. You'll see it now, how it works. It's hot. It's a little bit hot. Good. And you can see the casting here of the miniatures or the coins. Let's see, it's quite hot still. Very fast, very economical. So today our goal is to go through a little bit on all the project. Let's start the presentation. Okay. And we are going to explain, I think during more or less 40 minutes, we'll go all the whole structure of SiOCAST. We want to see and want to explain the process. We want you to explain how the machine operates and works. And also, we want you to understand what are the consumables that are needed to operate SiOCAST process. And and there is a lot of questions about how we do the molds, how the mold making is performed, and we'll go through all the steps for the mold making process. We'll do then some castings. I'm sure that you want to see how miniatures are cast in the silicones. And we'll go through all in all the features of the system. And in the end time, we will be able to answer your questions about the project. Okay? So here is the most important question. Why SiOCAST? Why we made SiOCAST? Why are we making injection molding in silicone molds? You may ask yourself, are we a miniature company? And no. Are we a gaming company? And the answer is no. We are a silicone rubber manufacturer. SiOCAST is a spin-off of Conyx. Conyx is a company based in Barcelona with subsidiaries in Portugal and also Mexico. And Conyx's core business and expertise is in manufacturing high level and also high temperature resistant silicones for the world of spin casting. Our customers are using our silicones for making miniatures, but also for bell buckle production, for jewelry. And the company has been more than 40 years selling silicones worldwide, very specialized silicones that are able to withstand high temperature applications. So During more than 10 years, Kony has been doing a lot of R&D because our goal was to try to find new applications for the silicons. Spin casting is a very nice application. It's very simple physics and it works very well. But we wanted to push forward, to go to the next level. And we wanted to try to find and to discover the holy grail of silicon molding, which is the injection. And in that case, the injection of thermoplastics. This is a project that takes us a lot of time, lots of efforts. The project has been funded by the government, by local administrations, and with the private funds of the Cognacs company. And during the first years, we did a lot of R&D on the silicons, but then we wanted to improve the process. Let's try to make new applications for making parts with in the silicon. And here is when we started trying to push the limits and do the injection. 4 years ago, this was already obtained after lots of efforts, and we got the patents, and then we start working on the process in order to make what you have in here already, which is a finished product. It's the machine, you have the silicons and you have the resins already available, so you can also incorporate this process into your manufacturing company. So all in all, Cognacs still is making silicons for mold making. If you are into spin casting, I encourage you to discover spincastingmolds.com, which is the website of Cognacs, where you will find lots of information about silicons and machines for your application. Okay. So let's see how is silicon manufacturing. As I was telling, Cognacs is a silicon rubber manufacturer. Everything is done in-house, from the design, the R&D, the manufacturing of the elastomers, also the testing, the QA, the quality assurance. Everything is it's proprietary from the company, and we have lots of flexibility and manufacturing capacity for making silicons. So when we came to SiOCAST, we understood that this application of plastic injection inside silicon had lots of advantages for the miniature manufacturing. Spin casting has, this sector has used spin casting as a way of creating miniatures. At the beginning, they were made of lead. Then lead became forbidden for safety reasons, and then we started making manufacturing with tin alloys. But then the price of tin went really high, and other technologies have emerged for making miniatures. In those cases, we also have resin spin casting. That is a system which is very, very time consuming. It's very aggressive for the molds, and also very slow and toxic. We also have vacuum resin casting, the hand pouring or pressure pouring, that it gives you a very, very high detail on the part, but also it's very, very slow. The molds are going to last between 20 to 40 castings, and it's also it's brittle material and not a lot of flexibility, and quite toxic also to operate. So also there are technologies like injection molding that demands very high initial investment for the molds. Also outsourcing them to Asia, that means not a lot of confidence, and also a lot of very high delivery time. We have customers with more than 8 months delivery time for the first sprue. And also you need very high MOQs to start manufacturing with injection molding. Then also restocking is very complex. It means that you need to also reinstall the molds into the machines and start with also a limited MOQ, which makes injection molding only available for very high volume. And also in some cases, when you work with PVC or ABS, the quality that you get is not the same quality that you would expect from resin castings. Okay. Also, there is additive manufacturing that is coming into the market, which is a very nice solution, but it's still very expensive for very limited runs, and requires a lot of time for cleaning the parts and the resins that are available at the moment are not very long-standing. So here is where SiOCAST really comes through. It's able to solve the major problems of all of those technologies, and it's bringing that into your factory. Okay, so because what we are doing is having the advantages of injection molding, we are doing like pushing the resins inside the mold, a mold which is flexible, that it's going to be able to have very high undercuts, and we can have a level of detail on the parts that will not add any cost to the manufacturing system. Instead, you have the same level of quality that you have in the resin casting, because silicon is going to copy all the details and intricate fine nuances of the models that you put and the masters that you are using for making the mold. Okay, so at the end, SiOCAST, what we have created is a new process. This is a process that has never been done, and here we had to adapt and have to design everything from scratch, but taking a lot of support from the other technologies. In order to make the manufacturing process, we start with the 3D design. I mean, you also can use, as always, the hand sculpting with a green or putty. And here, what we have represented is how straightforward it is to manufacture with SiOCAST. You start from the 3D design, then you 3D print. As I said, you can also use standard masters from like metal masters, not only 3D printing. Here is, we'll see this example later. This is a metal master. You can use 3D printed masters. We use different technologies for printing, but the most recommended is SLA or DLP technology, that it's going to give you the finest detail of all the other technologies in additive manufacturing. And but you can also use pure resin casts for making the masters, or even woods or acrylics that are going to be able to withstand the vulcanizing temperature. After the masters are created, then we make the molds. The mold is a technique. We are going to see that later on the explanation. We are going to see a short video of all the steps that are needed to make the molds. And once the molds are done, which require, like, let's say, no more than 4 hours of overall task, then we already go to the injection process. The injection process is going to be very straightforward. As you have seen, we'll talk about productivity, but you can do up to 40 castings an hour with the machine, that you will get your finished parts that you can already deliver to the customers. In order to create SiOCAST, we had to create 3 pillars, because everything is important here. We need special machine. This is the CO4 machine. That it's a custom design, and that injection process that we have to create in order to be able to perform this application. Would say that the most critical thing here was to control very precisely all the injection steps, and more important, the pressure of the resin inside the mold. The other pillar is the plastic. It's a material that never existed, that has never been developed in the thermoplastic industry, because the properties that it has are really special, are the ones that we require to perform the injection with the right pressure, the right fluidity, and the correct way in order to fill the cavities and copy all the details of the silicon molds. The other pillar of the project was the molds. Let's say that for us it was the most easy part, because we are silicon rubber manufacturers, and we know exactly how to create the molds and what type of properties we need to manufacture. But here we had to change the strategy, the mold making strategy. It's different from injection molding. It's different from spin casting, and we had to create a new technique in order to make the process works. Okay, so let's make a quick tour on the machine. Okay, I'm taking the computer. Okay. This is the CO4 machine. As you can see, it's really compact. It's a very, let's stop the presentation. Okay, it's really compact. It's like the size of a small fridge. It takes a little space. You can have your miniature factory in less than 10 square meters. And what you can see here is that the machine has the top side the injection module that it's going to produce the injection process. We load the resins on the top, and we have, as you can see here, a PLC that can control precisely all the machine parameters. Here we have the injection area, and in the front part we have all the pneumatics and the electrical cabinet. It's behind the machine. Okay, here what you can see in the machine PLC is that the machine can work with recipes. That means that you can store all the injection parameters of every mold into the machine. The machine can store more than 5,000 different molds that you can have sitting on the shelf. And when you pick a mold that is already set up into the machine, you will be able to simply press a button, and the machine is going to make the right injection process. Okay, as you can see, the machine also complies with all the safety standards for CE and also UL norms in terms of electrics. Okay. Okay, 1 second here. Okay. So, in order to, let's put everything back again. So, in order to have the machine, you only need air compressed in the factory. You will also need a vulcanizing press, and the machine is a 4.0 prepare. That means that it must be connected to the internet in order to operate and have software updates and improvements online. Okay, let's start again. Okay, regarding the resins here. Let's say this is a very important aspect of the project. You can see the resins here in the camera. They are supplied in forms of pellets. This material is as people are saying on the social networks and the products that are already released on the market with SiOCAST. People are in love with this resin because we have this slight flexibility. But material is still stiff. It's light. That means that when you want to compare with other technology, it's a light material. You can have infinite level of detail on it. Also, you will see that it's not brittle. You can throw the parts into the ground; they will not break, which is something that happens with metal or resin. You know the frustration of your customers when they go to an exhibition or a tournament and the parts get broken during the transport. Here it won't happen. So as you can see here, the level of flexibility it's very high. So, and then there is the painting issue. Here we tried a lot to make a special characteristic on the painting. Why that's that? Because people really don't like to clean the parts when they receive the miniatures. With SiOCAST, you can forget about that. You can forget about degreasing the miniatures. Also, if you want, you can paint straightforward without priming the miniatures. We've seen lots of positive comments on this application. Of course, sometimes for artistic reasons, people are going to paint or prime the miniatures for the given color. Okay, and regarding the safety, this is a common question. This material is really non-toxic. It's even EN71 certified that will permit you to sell it as a 3+ for board games or miniature games. You can sell it as a 3+ age because it has been certified by toy technology institutes, and we can deliver the certificates for the compliance of the toy safe norm, but also the material, you will see that it's free of cadmium, lead, and phthalates. Okay. The other aspect of the project was the coloring. Yes, you can put any color on the resin. We supply master batch, which is a coloring concentrate. Here you can see the basic gray that we deliver with the resin, but we can also supply other colors so you can make colored miniatures. Okay. Finally, you can see here the SiO mold. The SiO mold is the silicone rubber, and it's a HTV silicone rubber. It's not like the liquid silicone. That means it's a solid silicone. You can see it here that we supply it in laminates. This is a solid silicone. It has a putty consistency, and this is the silicone before vulcanizing. This silicone is extremely performant. We can do between 300 to 500 castings with every mold. That means that it's more than 10 times the life expectancy that you have with other silicones for vacuum casting or resin spin casting. You will get, when we talk about 300, 500, it depends on the level of the complexity of the parts that you will have maybe over time a lower life expectancy of the mold. But in general, we can see between 300 to 500 life expectancy castings, okay? And we also can supply different types of silicons. Here, I will show you the differences of the mold that you were seeing before of the coins, this mold. It has this is the 80 Shore A flexibility. It's quite stiff, and this is suitable for flat parts or parts that don't have heavy undercuts. When we want to talk about this silicone, is 65 Shore A. It's a much more flexible silicone. That means that you can cast much more complex parts that you will be able to remove from the mold more easily. Also, we can supply other type of silicones, you will see in the video in the next presentation, that are able to prevent detaching or tearing of the silicone in very complex areas. Okay. Let's see. Now, let's see how molds are made. Okay. So here is an example of mold making, one of the molds that we are going to cast. Those are the masters. There are 8 metal masters from a collection. And you can see here the mold frame. Those masters are 20 millimeters thick. That means that we will use like a 28 millimeter mold, which is 2 sides of 14 millimeters. Here you can see the texture of the silicone that we need first to apply it, to put it on the metal box, the vulcanizing frame, that then is going to go to the vulcanizing press. And the first thing that we do is we place you can see the external frame for the vacuum channel. We start placing the masters inside the cavities in order to distribute the layout. And then we can already start putting the runners. In that case, we are using Teflon rod runners that are, you can put it very easily to make your own distribution. Those Teflon rods are, I'm going to put pause. Those Teflon rods, we supply them to different thickness and sizes, and are very useful in order to make like modular runner buildings. But we have many customers that have very standard geometries that are doing their own runners with 3D printing, and they can already use those preforms in every mold, saving some time. As you can see here, we are using metal masters. They don't require any releasing agent. The metal masters you can already put into the silicone. We don't have any issues for the vulcanizing process. But when you are using 3D printing resin masters, you definitely really want to use like a special releasing agent that we supply that is specially designed in order to prevent those resins to stick from the silicone. If you don't use them, you will not be able to remove the masters after the vulcanization process. Once the masters are already allocated, we are going to use this type of blue silicone in those special cases where we have very complex parts and geometries. We call it the high tier silicone. This silicon is, as you can see here on the left top corner, it's a very special silicon that has a lot of elasticity. It's going to prevent the silicon to detach or to break when you are stripping the parts from the mold. Okay, so once all the miniature has their silicons, we firmly press it into the base mold, and we start adding the more silicon, because here what we want to do is to try to find and to bring the molding line where we really want. We want to prevent the molding line in delicate parts of the miniature, like in the front of the face. We want to bring the molding line in the laterals of the cape or behind the ear of the model. Finally, when this is done, you can see all the parts. We add the centering studs. You can see here that the centering studs are like metal pins that we supply that are going to attach both sides of the mold so they cannot move, and you will have very nice or very few molding lines during the injection process. These studs, they are different shapes that we can supply depending on the use, but they are very good in order to firmly fix the mold during all the process. Before closing the mold, we need to apply a releasing agent, talcum, that is going to prevent the silicons to stick together. When you don't use any releasing agent, the silicons, they merge together, but here we use talc. You can see that we apply it with a brush, and then we remove the excess with a blowing gun. Finally, we close the top lid of the mold. We close the molding frame, and we tied it very tighten. You can see with the nuts. This molding frame is specially designed for the machine. It will build all the centering geometries that need the molds to go into the injection machine. And we go to the vulcanizing press. This vulcanizing press is standard equipment on the market. What we are cooking here, the mold, it would be more or less 1 hour at 120 degrees Celsius. When the process is done and we let the mold frame cool down, because if not, it's too hot, we open the mold with the tool. We remove the frame, and then we already have the mold vulcanized. Next step is going to be to open the vulcanized mold. You can see now the rubber has this solid texture that you would expect. And you can see that there are already the cavities made. We need to remove the runners, the masters, the vacuum channel frame, and all the cavities are done. All the cavities with all the detail of the masters. Okay. Next step then is to open the gates of the miniatures. This is a trial and error procedure. We are doing the at the beginning we are doing the gates by trial and error. All this is a technique that we really we train during the training program when you buy the machine. Would require several iterations in order to have this set up. The beginning, once this is done, we need to open the gates. We need to open the air vents for that connect the cavities to the vacuum system. We put the mold into the machine. We start with basic settings that are going to be very safe. And here, this is the live process of the first injection that is going to happen to this mold. And you can see here the unbalancing. The first shot is never going to be okay, of course. You can see some cavities already 100% filled, or others like 20%. Others, they had any material. So here we start to with the technique that we teach, we start to proceed with opening the gates or playing with the injection parameters until we have the mold already set up. Depending on the skills of part complexity, this would take between 5 to 15 castings. So in less than, let's say, 1 hour, you already have the mold perfectly balanced and ready for production. You can see here that this mold, after 7 shots, it was perfectly set up. As I said before, the injection parameters are already stored into the machine. You don't need to do anything else. maybe sometimes you need to make some adjustments depending on the temperature of the mold, the silicon, but you can see here that we have like an exact copy of the master, and you can see here that the resin will look even sharper than metal, because metal is shiny, you don't see all the details on or the small nuances or the shadows of the model. Good. So this mold making process needs it's a skill that we need to train. The training of the machine normally it's 3 days, and now with the current situation we are doing the trainings online, but this is something that you can master more and more. But after 3 days you get all the skills in order to start your manufacturing production without any issues. Okay. When we talk about the molds, I like to highlight that we can play with different thickness of molds, from 8 millimeters per layer, but we can make up to 60 millimeters thick molds. That means that you can use, you can make parts from like very thin wall, like 1 millimeters, up to 40 millimeters thick, like thick miniatures, which is quite a lot. Of course, the thicker the miniatures are, the more time you will need for the castings, because this is a solidification or cooling process. And of course, the resin or the silicons are not very don't have a very high heat transfer coefficients. So the thicker the part, the more slow the process is going to be. But this is not really an issue, because you can cool the molds inside of the machine, but you can remove it before the opening of the mold, and you can let them cool outside. And during these times, you can start casting with new molds. Okay. So now let's go for the live casting. I wanted to show you, because this is, I think, this is what you wanted to see, really, how miniatures are cast. And here we have prepared several molds. This mold is the same one that you show in the video. This mold is okay. We need to close the and to align both sides of the mold. And now we're going to put it in the machine. While this injection is done, we can already prepare the next mold. As you can see here, this mold it's a demo mold, has several type of miniatures. We have from miniatures, bases, tank tracks, and all those molds, some of them, let's say, they require a little bit of releasing agent before casting. Now I already apply it. It's we use talcum, the same as injection as spin casting. We sell and we supply this type of industrial talcum for these applications. And as you saw in the mold making procedure, it's going to be like the same type of activity. When you are into production for SiOCAST, normally you can do you can have only one person here in the factory, or you can even have two. Depending on the speed and the thickness of the parts, you will be able to do between 20 castings an hour, or up to 40 if you have 2 persons operating the machine. Normally, there's one guy applying the talcum, closing the molds, and operating the machine, and the other guy is opening the molds, stripping the parts, and making a small quality check. Okay. As you can see, I simply introduced the new mold, I selected the recipes, and the injection process is done. This is you can see it here, the casting is done. And now you can start stripping the parts from the mold. You can see that we have the sprue here, one. Okay. Now this mold is finished, and we are going to cast this other mold that is a sample mold with different parts. You can see like a 75 millimeters miniature, like a dwarf, also warriors, bases. And you'll see it's not been casted. I pressed the wrong button, sorry. 1 second. So all in all, what you are having is a very fast productive process. When you're into production, the only thing that you need to take into account is to prevent the silicon to heat up. So this is why normally we are rotating different type of molds, so that we let them rest a little bit of time in order that the heat doesn't build up. It happens the same as in spin casting. When the silicon is too hot, you can have flashings or miscast because of the temperature. Okay. Okay. Here it is. We will let it cool a little bit more time, this one, because parts are thicker. I'm going to cast again this one. Okay. Here we have it. Maybe it's still too hot. You can see here, miniature. Or this pilot. Okay, this mold is already. Here we have it. As you can see here, we have technique of making the miniatures in a small screw, where you can see that you simply remove this part from the mold, and you can put that already into the box. We have here also some tank tracks. Or miniatures with their own bases. Into the mold. Okay. So let's start again with the presentation. What you have seen here is what features brings advantages to those miniature manufacturer. So SiOCAST brings you lower costs, many very important lower cost of production, because when you want to compare it with metal production, spin casting, you will see that the density of the resin is 7 times less than the density of metal. Also, you get lower costs against resin casting because you have 10 times faster productivity, and also you have over 10 or 20 times more lasting silicons. You need to understand how much time you will save making silicon molds when using SiOCAST against hand-poured resin. Also, productivity. Would say that it's even twice as fast as metal casting because the cooling of the resin is faster, but also against resin, you don't have to wait all that time for the reaction to move from the pressure pot to the vacuum pot. SiOCAST, as you've seen, it's very fast. You can do up to 40 castings an hour, 45 depending on the miniature, which means that you can do in a production mold. If imagine that you can put 32 mils in a single mold, you can do more than 500 miniatures every hour. Okay. Also, shorter delivery times. When you want to compare against injection molding, miniatures that are made maybe in China, you have very long delivery times. Here in SiOCAST, you can make the mold in 3 hours since you get the masters. Let's say that you make the design, you 3D print it overnight. You need several hours for cleanup, but then you can already make the mold. You have already the mold into production. That means that the initial investment is really low for the miniatures and for every game you want to release. And also you can make mistakes. That means that if there is a Kickstarter that it's not going to succeed, you can, the investment in molds, it's really, really low. When you are investing in steel tools, you need very high MOQs and an upfront investment, which is very risky. So here we are reducing definitely all the risk on your business. Also, let's talk about weight. There is people manufacturing with metal are being able to sell their products far away, because when you are manufacturing maybe in the UK and you want to sell your games in Australia, sometimes the transport costs are higher than the price of the minis themselves. So when you are able to deliver this level of quality and also this level of detail in the miniatures, but it's 7 times less transport weight. So this is opening your markets. That means that you can widen your market for selling your miniatures. Also with SiOCAST, as you've seen here, there is a stock reduction. You need to produce only what you need to sell. This is just-in-time production on demand. If you have to do 120 castings, you can do it with the machine. If you need to restock 300 more copies, you simply you take the mold from the shelf, you put it in the machine, you select the recipe, and the machine is going to cast the exact miniature. Okay, and then we are talking about the material which is safe. That means that you can sell your product to more audiences, because being non-toxic and EN71 safe, it's going to be able to open the scope of your customers. Okay. So what is your customers going to receive? It's going to receive parts with far better detail than other technologies, or as I said before, we have, when we compare metal against resin, you can see much better detail on the resin cast than on the metal cast. Okay. People can have, as the manufacturing costs are quite lower, you can even sell more miniatures with the same price. So people will accept your products better because you can deliver more miniatures for the same amount of investment. Also, people are loving the flexibility, and that means that they understand that this flexibility means that the parts are going to last longer. The painter is going to adhere better, and because there is an important factor. Even if you bend the painted parts, the paint is going to attach. It's not going to break or peel off, as happens with resin or metal or HIPs. So this is it has been very welcome. The miniatures that are around the market and the companies who are selling their products with SiOCAST are very, very happy with the feedback of their customers about the painting capacities. Okay. And thanks to the undercut, you will be able to make very more robust parts that they don't need so much splitting on the steel molds that you have to do. That means less time for assembling. Okay. So all in all, what we are saying in SiOCAST, like a final resume, we are talking about, we get high productivity, you get the tooling in less than 1 day, and you can make from any collection from some dozens of copies to 100,000 miniatures. So we'd say that it's over 10 times faster over resin casting, sometimes even more. and we can compare the productivity to injection molding. Okay, the detail, you get all the detail that you get with the high level quality or high end quality of resin casting, and with more detail, with lots of details that you don't have with injection molding. And also the cost. We want to explain the cost, manufacturing cost. Here is a very clear return of investment. People are really paying the machine in very short time because of the cost reduction in manufacturing. You get, let's say, between 50 to 40% less than in resin, and also 60% less than in pewter, because there is that density difference on the miniatures. Okay. When you want to compare also against resin casting, you have to take into account that the resin is 10% less density than the pure resin, but also the mold life is going to be so much longer that you are going to save lots of time and lots of time making the mold making. Okay, and here there is a small video when we want to transmit and share this information of why this is okay. Cheaper than metal. This is a 1 kilogram pewter ingot. You can make with it 45 miniatures. This is 1 kilogram of resin. With it, you can make up to 335 miniatures. This is where the difference is, because the density is so different and the weight is so different that you can really make with 1 kilogram of material, raw material, you can make up to 7 times more production. So here it is. Now let's wait for your questions and answers. We are glad that you listened to our webinar, and we want to answer all the questions that hasn't been during those slides haven't been responded. Okay. I see that John is asking why there are different type of silicons. Okay, this is because we have every color of silicon means a different hardness. That means that you can use all those silicons for different complexity parts. As I said, when you have very flat parts like this coin, you want the mold to be as stiff as possible to preserve the geometry, and also when you're having like high complexity, you want the flexibility of softer molds. Okay, some of us are asking about the price of the machine. I encourage you to contact us. I will send you my final email here. I encourage you to contact us for a pricing quotation of the machine, the resin, the silicons. Let's say that this is like a small Tesla, but you'll find it very interesting. So send us a contact for the quotation. So what about the cost of the resins? Also all this information is going to be sent by email, but you will have manufacturing costs lower than China, definitely. Making one of those minis or one 32 mil or 28 mil mini, it's going to be much more cheaper than making it in China. Also between 2 or 3 times cheaper than make it in resin casting, or 6 to 7 times cheaper than make it in spin casting. Okay, so some of us, are you asking about the toxicity or the area or the safety precautions in the installation? We are, no, material is not toxic. Even the vapors are not toxic. Although we recommend companies with small workshops to install like extraction vents for the fumes of the machine. Normally with the machine it's operating, you have the lid closed, there are not fumes. But when you want to open the melting hopper, you want to use like a mask and gloves and some goggles not to inhalate the direct fumes from the machine. But this is something non-toxic, and it's a matter of agenda. Okay. Some of you are asking, I see Peter who's asking about how much times you can print the same mold. You can use the same mold normally between 300 to 500 castings. You will keep the detail perfect during all these lives. And when you see at the end of the life of the mold that maybe some of the silicon details starts to detach or to break, and this is when you want to consider manufacturing another mold for that. So also, yes, I'm asking some. Now that yes, we are. Some of you are asking about samples. Yes, we can supply samples. Here I'm going to. 1 second. Yes, what I wanted to ask you is, now that we know each other, that you have seen how the process works, we want you to encourage to make the next step. Here is that we are able to service you. We are doing this type of, we are making test molds so that you can see how your parts are look like with SiOCAST. All that we need is your masters. We need to check them before in order that they are castable, and there is a small cost on the mold making. We can send you all this information by email, and if the molds are you can, as you can see here, we can make with the same mold different type of parts. We try to make them as balanced as possible, but if you send us your master, you will be able to see how your miniatures look with SiOCAST. Also, we can send you samples. If you are interested in receiving like a box of samples with these miniatures that you can feel and touch, how is the resin, the flexibility. You can even paint them to understand what is this non-priming advantage, so we can supply them to you. Okay. So this is all. If you have any more questions, please call us, send us an email. Please follow also on social networks. Here you have my contact, my email. Also, you can follow us on the Instagram, Facebook, Twitter, LinkedIn, or YouTube. And thank you very much for your time. I hope you enjoyed, and I hope to see you soon. Thank you very much. Goodbye.